let us talk about command line arguments. What are command line arguments and how do we deal with command line arguments in C? But before we talk about how to pass command line arguments, how to receive them, and so on, let us first understand what happens when you compile a C program. So if I take a program like A.C, when you compile the program first, you are converting this to A.O. Of course, in some compilers, it is called as OBJ. Whatever is the extension, it means we are creating object code, also known as mission code. So A.C becomes mission code with A.O or A.obj. Now this is then converted to A.exe and this becomes executable file. And if you are using Unix or Macintosh, OS X and some other platforms, the extensions might be different. I'm talking about Windows, and precisely I'm talking about compiler like GCC, which you get through code blocks. So A.C is compiled to mission code, and this mission code is then linked to libraries. So when libraries are linked to mission code, you get the executable file that is A.exe. Once this exe file is created, you don't need anything. You can just directly run this. You can give it to your friend who is working with Windows. He can run it. You can run this as long as you have Windows. You don't need anything about C because this exe is self-contained. It contains everything you need to have to run the program. So the object code is linked with libraries. This is where you get code for printf, scanf, and the rest. And when these two are linked together, you're going to get the final version. So this is where you are actually compiling it. So you compile here, and this is where you're linking this with that, and this is called linking. You link libraries with the object code, and eventually you get A.exe. Now, once you got this exe file, you can run it directly from command prompt. So this is my command prompt. Directly from command prompt, I can say A. I don't need to say .exe because that's automatically taken, and I can just run it and it runs. And I don't need anything else but A.exe. Well, if you want to make it more explicit, you can say A.exe, but anyway, that's not needed. So this is how we can run the program, and it runs, and whatever A.exe is designed to do, it is done. So let's see how we can run the program from command prompt, and then how we can pass some input to this program from command prompt. So from command prompt, it is possible for our program to take some input and make use of it. At the time of you running your program from the command prompt, it is possible that you pass some parameters to it like this. And these are all called command line arguments. So these are command line arguments because this line is called command line. And these are command line arguments, also known as parameters. So how can I pass command line arguments, and how do we receive them in our C program, and how we can make use of these values? To understand all that, let's write a simple program. First, let's create a program without command line arguments, and then we modify the program to use command line arguments. So it's a simple program. Let's say program to take a number and print factors. We just want to print factors for the given number. So let's say we create a program and this is main and we want to take a number. So we say int num and we need I and say printf. This is where we take, this is the normal version. I will modify this to make use of command line arguments just to show you how the normal input and command line input would differ. So enter a number and take it using scanf %d &num. Now just go with the loop. I is 2, I less than or equivalent to num by 2, I plus plus. I'm not considering the numbers, one and itself, because you know they're always factored, so I don't consider. If the number is divisible by I, then we print it. So we say printf %d, and you can give some space. So you can give some space on the right and say I. You just want to print. That's all. My program is done and we are going to save this and then run it. So I'm going to save it somewhere, doesn't matter. So we are going to save it with the name factors.c. That's the name I'm giving, factors.c. Now the program is compiled. If you go to that particular folder where we saved it, I actually saved it in classroom and then September 3rd. And there you can see I got 3 different files. Factors.c is the source file. Factors.o is the object file. Both of them are small. But factors.exe is huge. You see something like 29 times the size of the C file. It's because it is going to bring a lot of code from libraries. And this is what we are now interested in. We run this. Every time you run the program, every time you go and run the program, you are actually running that. And look at that. That's so clear from this. So when you run a C program, you are running the .exe file. And then when you enter a number like a 245, it's giving all the factors. So those are the factors for 245. Fine, but this is the way the program works. And you can now run this program from the command prompt. So I can jump to command prompt. Let's go to command prompt and go to that particular folder. And then there you have your factors.star. You see those 3 files. And I can directly say factors. And it is running that factors.exe. So it says enter a number. I enter a number. And it is giving me all the factors. Cool, right? I can write a program, run it directly from the command prompt. And whenever I run, it'll ask me for a number. I get all the factors. Nothing wrong with this. You can give this .exe. Again, remember, just .exe. You don't have to give C or O. Just .exe can be given to your friend and your friend can run it in his system and he doesn't need anything at all except a bare Windows operating system. Because the exe contains everything and many just don't understand it. They think they should have C compiler, something like code blocks and all. No, that's all not right. Just exe is all that you need. But of course, your platform must be Windows. Okay, so I can run this program like this. And when I run this, it's asking me to give a number. And when I give the number, then it is giving me all factors. I want to change the way the program works. What is that? When you talk about programs like type, which is a program provided by operating system, if you just say type, it won't ask you for any input. It says, sorry, the command is incorrect. Because type is expecting the program or the file. It says, give me the file so that I can display that. Like this. You have to give the name of the file that you want to display. And then it is going to display. So this is a program expecting some parameter. And this parameter is given to this program. This is given to it. The program takes this, the file name, it'll open it, it'll display. So can we do something similar to that? Can I say something like factors and give a number there itself? I don't want to take any input by prompting the user. Instead, I expect user to provide input right at the time of running the program. So when user says factors 345, we don't want to ask user anymore. We take 345, make use of it. Can we do that? Well, right now that's not happening. I have to enter the number, but I want my program to change to receive input that is given on the command line. This is called command line parameter. And this line, this whole line is called command line. So any parameter you give here is called command line parameter. So how do we do that? Well, to receive parameters given on the command line, we need to make two changes to our program. Number one, we have to include two parameters for main. Now, main receives some parameters. The second one is called argv, which is an array of character pointers. In simple words, an array of strings. Now, this indicates how many parameters you have on the command line. So, if you take this, if I run this in this way, now this program and the parameter, these two are copied into this. These two are copied into this array. Now argv is containing two elements and argc contains the count. This is 2 now because I have two values there. It always counts the program name. It is not just taking only the parameter. It takes the program name. So argc is 2 and argv is an array of 2 elements. The 0th element is always the program name. So it's going to be factors. And the second one is 345. This is the first element. So whatever you pass from the command line, that is copied into this array of strings, and the count is here. Only when the count is representing the number of parameters you want, you should proceed to take the values. In this program, I expect at least one parameter. So count should be 2. If it is 1, it means user forgot to give this number. Okay, let's first look at that. So this is gone. I don't need this anymore. I don't ask user to enter the number. I want to check whether the parameters are provided. If the number is provided. So argc is less than 2. That means what we wanted is not provided. What do we want? A number. If argc is 1, it means the second parameter, the number is not provided. So I just display a message saying, sorry, number is missing. Well, there are different ways in which you can indicate the error to user. You can display message like this, or you can give syntax. When you give syntax, like you should say factors followed by number, then user understands, okay, I have to give a number after factors. It's up to you. You can choose whichever way. Now, don't proceed any further. You have to stop the program. You stop the program because the required input is not given. But if the required input is given, then you are going to proceed. And what do? You're going to take that argv of 1, because argv of 0 is always the name of the program. But argv of 1 is what we are interested in. But we want that to be a number. So we convert this to a number. The string is converted to number. There is a nice function called a to I, which stands for ASCII to integer. That means we convert a string to integer. This is how we convert a string, because though it is a string, we know what is inside this is a number. So we convert this to a number, a to I, and once we got the number, the rest of it is same. There's no change in this. Now, we just want to build it, and you don't want to run it now, because you have to run it from command line, not from your IDE. Don't run it from IDE. Okay, just go build it, and once you build it, don't run it. In case if you run it, you get the message saying, sorry, number is missing. Because obviously you are not passing anything, so it gives that message. So instead, you have to go and build and come to command prompt and run it from here. Now, if you run this program from command prompt like this, you're going to see the factors. So whatever number you give, it takes that number. It is in the form of a string. We convert that to integer, and then we are trying to display the factors. In case if you call the program, invoke the program without any input, you get the message saying, sorry, number is missing. So this is how you can provide command line arguments, receive them in C program. And this is a concept you see not just in C, almost in every language, like you see it in Python, you see it in C#, Java, everywhere. So sometimes it is more convenient to write programs that take input on the command line and make use of that input. In fact, you can develop some beautiful utilities, some useful programs, which people can just run from the command line and get the job done. So this is about command line arguments in C. Now, let's see one more example just to get better idea. And this time I create a program called a table. This is just going to generate a table. We call it as table.c. And this is going to take a number and print table. And it is going to print table. Now, what is the table? So again, we expect at least 2 parameters. If not, we stop. We convert the number, and this is the table. The table should go from 1 to 10. And this is where you just simply print. It's going to be even more simpler. So percentage %d, okay, into, and we need to say 2 into percentage %d, let's put 4, is equal to percentage might be 4d or even 6d, and then \n. So this is where we are talking about the number I, then num, I into num. That is what you need to print. So this is expecting a number and converting that to integer and going from 1 to 10 and printing the table. And we want to print 2-digit number first, then 4-digit number, and the result is 6 digits. At the most 6. It's not that it's always 6. Now let's just build Don't run it, just build it. Come here and then run it. So table 15, you get a table like that. If you say table 15, you get a table. This is the way you can generate a table. But I can make it more interesting. I say, well, this is the number. But what if I want to have a table of 20 numbers? I want the table to go up to 20, not 10. The length of the table is 20. Right now, it's not doing that. So let's add a little more spice to it. So here, I say the length of the table, by default 10. But in case if user is giving 3 arguments, if argc is greater than 2, that means we got the third argument, then we say length is equal to a2I of argv of 2. That means we are going to change the length to this. We can put it like this. So only if argc is greater than 2, we take that number, convert that, and that becomes the length. And here it is not 10 anymore, it is length. And if nothing is given about length, we settle with 10. But if it is not 10, then we go for it. Now let's go set and build it. This is the way you build. And now go and then run this first version. It is the same old story. But if you give something like 20, you get numbers up to 20. Of course, you can give something smaller also if you like. This is the way it goes. So you can make your programs more flexible by giving more parameters. There's no limit. You can develop an application with lots of functionality. And in fact, sky is the limit. You can go as high as you can, and you can include as many features as you can. So this is one way to pass input to your program, and your program is receiving that input and making use of the input. So you can develop some programs like this. These are some simple but interesting programs. You can think of adding a lot more. Now, let's see one more example for this, where we are going to develop a program. It's going to take multiple files, but how many we don't know. As many as you give, it'll take all. And it is going to display files with line numbers. Now, let's create a new program. Now, what this program should do, let's start from the beginning. Okay. Now, I want to create a program. We call it as print source. The name of the program is print source. It is going to display the source code. And if you give the file names like a.c, b.c, and then table.c, it is going to display all these files one after another. This is a.c, then b.c, then table.c. It displays each and every file along with the line numbers like this. It's going to display the line numbers, and then it is going to display the file. So how do we do this? Now we want to create this program. Let's go try this. So this is about print files with line numbers. But those files are supplied, print files provided from command line. Whatever files provided from command line, I want to take all those files and I want to make them available to program. So let's do the routine thing, then main, but this time argc character star argv. Well, should we name it as argv and argc only? Not necessarily, but that is the convention. Better follow it. You can name them as anything. After all, they are just formal parameters. You can give any name you like, but it's better you give the standard name so that people can easily understand. Okay, what next? You need to open one file at a time and display. So file star fp, and we also want to read line by line. So we need a line, and we talk about something like 200 characters in a line. That's the maximum we assume. Then we talk about line number, and these are the variables we need to have. And we start with okay, one more call I. So for I is equal to 1, that's the index of the first file in argv, because argv of 0 is the program name. The file name start from argv of 1, and I less than argc, it goes up to the end, and then this is where you need to do it. I less than argc. And what you need to do is you need to open a file like this. So fp is equal to f open. Open the file, that is argv of I. This is where the file is present, and open it as text file. rt read text. You're opening argv of I. The ith element is the file name. But if fp is null, what do you want to do? Well, you can display message saying sorry, file cannot be opened, or you can silently ignore it. Okay, I just want to display message and then move to the next file. So I say something like \n and then %s not found. Or you can be more descriptive saying file %s not found \n and then argv of I. That is what you did not find. And then continue. Well, we are not saying break. We are saying continue. That means we ignore the rest of the process and we'll go back to the next iteration. But if the file is opened, then we need to go in this way. We want to open the file, check whether it is opened successfully. If it is opened successfully, we go to the while loop, read one line at a time like this, f getS, then line comma 200 comma fp, and if this is null, it means we reached the end of the file, then we break the loop. Otherwise, we print it. And also you need to start the line number with 1. And we need to print it here, printf %4d, and you can also give 0 4d, assuming that your line numbers can go up to 4 digits, and then colon %s, and comma, you give line number, comma, line. This is what you need to do. And then after that, don't forget to increment line number. So we print a line at a time, and the line is printed along with the line number. This %s is representing the line, and the line is already having new line. So I don't need to again separately display new line character. And at the end of it, make sure you close the file. So this is the process. If the file is not found, just ignore it. If the file is found, display each line of the file. You may want to display the file name so that user knows which file you're printing. So I would like to say something like this, some stars, the file name, and a few stars. This is how I want to display the file name, argv of I. So display the file name, and then you display the content. And at the end, this is end of your for loop, and this is end of your while loop. That is while loop, which is going to display the file. And this is the for loop, which is going to take each file that is provided on the command line. And one more important thing, you might want to have some gap between the files. And in that case, you can increase the space. You can have 2\n so that there is more gap between files. You can put it like this. Anyway, that's all cosmetic stuff. You can do whatever you like. Let's go and call it as we discussed print source.c. And this is built and all is well, no issues. Everything is successfully compiled. Now let's go to command prompt and then try to run it. Now, do we have any files there? Yes. We got table.c and we got something like factors.c and we got then, of course, print source.c. We can print them. So I say print source table.c abc.c and then run. You're going to see table.c, but you're also seeing an error message saying file abc.c not found. Maybe you need to highlight it a little because that message seems very plain. So you can say something like this. Okay, you can give 4 stars and say percentage this is not found, another 4 stars. Okay, so build again and run. And this time you're getting the error message a little more prominently. So this is the first file. And the name of that is table.c. Now if you want to print one more, that is something like factors.c. Now you say print source table.c abc.c factors.c. abc.c is not there. Intentionally we are giving it. Now run and you can see something like this. This is your table.c and then you see abc not found and factors is found and we are displaying it. Well, it's up to you. You can make this even more prominent by giving more stars or giving border for that, all sorts of things. But if you see the content, that's fine. The programs are fine. This is the way. There's no limit. You can provide a lot more functionality. For example, you can provide flags to this, and based on the flags, we decide whether to print line numbers or not. So you can provide something like flag. Okay, I'm just giving you some idea. I don't implement it for now. But you can say something like minus L is about line numbers. Okay, if you give minus L, then line numbers are displayed. But if you don't give, no line numbers are displayed. Or you can say minus O, this is about to turn off the line numbers. So you can design, you can think of what flags you want to give and how the flags are to be interpreted and processed is your choice. There is no universal thing about it. You know, if I say dir/w, it displays files across instead of vertically. The flag is processed by this program. Like this, we can process whatever flags we want. So you can enhance the program to support flags. But for now, this is how you create a program that takes as many files as user gives, and it is going to display each file along with the line numbers. But if the file is not found, it simply displays a message saying, sorry, file not found. And then it just ignores the rest of the process by continuing with the next iteration. So from there, we go back to the next iteration. That's how continue works. So this is a program, and like this, you can think of a lot more programs. This is just to give you some idea.